If at all any mistakes in the syntax, maybe a semicolon, maybe a comma, full stop, if anything is missed out, those are called as grammatical errors and referred as syntax error. The problem into three subproblems. Again, this is a subprogram, and again this is divided into smaller programs, again subprograms. We are looking into the particular data and we will pick out or will take the respective data to get a module for a particular module. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysore. Students, let us continue our discussion with the topic types of errors and approaches to problem solving. So, in our previous session, we have learned about the different steps involving in problem solving. So, here, now let us go to next slide. Characteristics of a good program. Now, we have learned what is a program so far. So, what are the properties or characteristics of a good program? So, the best program, we say best program or algorithm to solve a given problem is the one that requires less space in the memory and takes less time for complete its execution. And the meaning of the statement is, suppose we would like to say, or we can say this program is very good based on the two factors. One is the memory space required in the computer memory for a particular program, as well as the time taken to execute the program. So based on these two factors, we can say which the program is the best program, or this is the characteristics of a good program. So, and also it should be modification. I mean, a good program is the one which allow any modification easily whenever is needed. Now, because suppose if you are using any other one software or any program, so suppose if any user or any programmer he would like to make some changes in the program, so that the program should allow the user to make modifications. So this is one of the character. And also portability. A good program is the one which can be run on different types of machines with minimum or no change. See, what is the meaning of portability? The meaning is a same program can run on different computers with or without any changes. So accordingly, we can say that a good program is the one. So it should run on different types of machines or different computers with or minimum changes or without any changes. So these are the characteristics of a good program. A good program is the one which takes less space in the memory and executes very fast, and also it should be in a position or it should be modificable or it can be modified as per the requirement, and also portable. So the program should run on different computer. So next one is types of errors. Now here we know what is a program now. So whenever we start writing a program, there are chances of doing mistakes. So there may be different types of errors. So accordingly, there are four types of errors. One is syntax error, semantics error, logical error, and runtime errors. So errors in a computer program can be classified into different type or these types of errors. Now let us see the definition of syntax error. So what is a syntax error? The grammatical mistakes in the statement of the program are called syntax error. As all of you know that each and every language has its own syntax or protocols. So we have to follow the same. Similarly, if at all any mistakes in the syntax, maybe a semicolon, maybe a comma, full stop, if anything is missed out, those are called as grammatical errors and referred as syntax error. Next one is semantics error. What is semantic error? A semantic refers to the logic, so which should be followed while representing the solution. The wrong use of logic in the program is termed as semantic error. So here every problem or every program has its own logic. So your program instruction must follow the same logic. So if at all any problem or not in the same order, any problem with the logic of the solution, then it comes with a error that is referred as semantic error. So semantic error is generally any problem in the logic of the program is referred as semantic error. Next one is logical error. If the correct translation of algorithm causes the program to produce wrong result. So the meaning of this one is, now you know what is a translator, isn't it? Here every program written in any of the high level language, it has to be translated, or we have learned algorithm. So what is algorithm? It is a step-by-step procedure to solve a problem, and which is written in general English language. But if I talk about a program, see what is a program? Here we are converting algorithm or flowchart into a program by using any of the high level language. So any problem or any type of problem with respect to translation of algorithm into programming causes logical error. So this is called logical error. So once the translation is not in the order or is not proper, obviously we may not get the desired result. There are chances of getting wrong results. So this is logical errors. Next one is runtime error. Errors that are detected during the execution of the program is called runtime error. Now, whenever we are executing the program, though first we are writing the program, then we'll check for errors. That is called compilation. When you compile the program, we will come to know the different types of error in our program. So that is called debugging. So once debugging is done, then if our program is error free or no errors, then we have next step is to run the program or execute the program. So there are chances of some errors during program execution, or during when you run the program, there are chances of errors come up, or it shows those type of errors are referred as runtime error. So these are all different types of errors may occur in our computer program. Now let us move on to next concept, that is approaches to problem solving. Approaches to a problem solving. Here in general, if any problem given to you or any students, the first step is we have to think of the problem. So it is also important to how do you approach the problem. Means in other words, we can say how do we start think of the problem so that it is easy for us to get the things done or to get the proper result. So this is nothing but approaches to a problem solving. So here basically there are three designs, or there are three methods. One is top-down design, stepwise refinement, and bottom-up design. These are the different techniques used in problem solving approach. Now let us see this one by one. So first one is top-down design. It involves dividing the problem into subproblems and further dividing the subproblem into smaller problem until it leads to that can be implemented as a program statement. So what is the meaning of top-down design? Here as per the definition, so any program given to you, normally the human tendency is we divide the problem into subprograms and or subproblems, and again we are keep on doing the same process till we get the final result. That is the top-down design. So for example, look at the schematic diagram here. So for example, the problem is given here A. Suppose you assume that this is one problem. So this problem now we are dividing into sub-problems. For example, B, C, D. We are dividing the problem into 3 subproblems, and again this is a subprogram, and again this is divided into smaller program or again subprograms. So we are doing it till it is possible for us to write the statement for this final stage. So this is a top-down design. So I repeat, students, top-down design is nothing but dividing the given problem into subproblems. And again, these subproblems can be divided into smaller problems depending on the problem again or the instructions. So we have to keep on doing this process till it is possible for us to implement as a program statement. Means this one we can easily implement statement for this particular stage. So this is top-down design. This is one of the approach. Now, advantages: it imitates the human tendency to solve a problem, outlining the broad concept first and then subsequently going into the details. The details can be worked out with no or with changes. So this is normal human tendency. Any problem given to us, normally what we do is we try to divide it into subprogram. For example, any problem given to few students, so you are going to divide among yourself into number of subproblem or subtask. That is as an example for this. And the assumptions at level continues, and the development of next level subprograms can take place in parallel. So if you look at the previous diagram here, schematic diagram here, see here we have divided the program here. This is one program. Simultaneously, this also is executing, or simultaneously we are also getting solution even for second subprogram. Similarly, even for third subprogram. So the meaning is that at a time all the subproblems are getting solved or is working on different subprograms simultaneously. That is the meaning of the second point. Next one is the programs can be developed easily, quickly, and committing a minimum number of errors. So another major advantage is that it's easy to implement this and easy, fast, and with minimum number of errors. So this is top-down design. Now let us move on to next technique or second method, that is stepwise refinement. The process of breaking down the problem at each stage to obtain a computer solution is called stepwise refinement. Here the meaning is that, and we are going to divide the problem at each and every stage. For example, input stage or processing stage or even output stage. So if at all if there are number of stages, and each and every stage we are going to divide the problem so that to get the computer solution. For example, see this is one problem given, and here there are 3 sections for this, or we can say there are 3 stages. One is input status, and this is body of the algorithm. Next one is output. So if I talk about data processing, one is input, process, output. So in our program, if at all the problem is given, we are dividing into 3 stages: input and processing, or it may be a output. So here input condition is the one stage, and here we are thinking of types of inputs and similarly types of output according to the inputs given. And between you have body of the algorithm. Here again the body nothing but processing. Those steps again we are dividing into subtask. It is also a subprogram. Again these subtask 1 is again divided into subtask 1A and 1B. So this is a process of breaking down the program at each and every stage till we get the final solution so that we can implement a computer statement. So this is stepwise refinement. Next one is bottom-up design. So another technique is another method of approaching a problem solving is bottom-up design. Here this approach is reverse of top-down design. So in top-down design, what the definition we have learned? we are breaking down the problem into sub-programs or sub-problems. Similarly, it is reverse of top-down design. And the process starts with identification of set of modules which are either available or to be constructed. So the meaning of the second statement is here, if we are not going to divide the problem here, but what are all the data available in for particular problem, we are looking into the particular data and we will pick out or will take the respective data to get a module for a particular module. That is the meaning of the second statement here. That is identification of set of modules to solve a problem within the data given or within the solution. That is the meaning of the second statement. Next one is an attempt is made to combine the lower level modules to form modules of high level. It is nothing but we are going to do it from the scratch. I mean to say, first we are going to find out or we are going to identify different modules or different parts for our solution. So then we are going to combine all these things to get a meaningful result or to take us to the next level. And this process of combining modules is continued until the program is realized. So until we get a shape for our program or solution to a problem, we have to keep on doing this process. In this case, small subtasks are implemented and tested first, and then those such problems are combined together to give a large solution to the entire program. So this is, we can summarize like this. So bottom-up design, it is reverse of top-down design, and here it is a process of, first of all, identification or finding the modules for our program. So we will define or we identify number of modules or number of sub-programs for a problem given, and those problems, sub-problems or subtasks, it can be tested separately. So once if we are convinced with that, so we are going to combine those subtasks in together to get one main program. So this is a bottom-up design. Students, in this session, we have discussed about the types of errors and also the approaches to problem solving. Now, we will continue our discussion in my next session. Thank you very much.